Microemulsions are a technique of chemical synthesis of nanoparticles which is considered to be very effective because whatever chemicals are made use of in this technique and whatever products are synthesized in this technique, they are biologically compatible and they are also biodegradable. You know that whenever two immiscible liquids are mixed and forcefully stirred, they give rise to an emulsion. And in this way, you can also make micelles and inverse micelles. When you talk about micelles and inverse micelles, let me show you what it exactly means. So when you are going to mix, let us say, fats into water, you will see that you get normal micelles. So when you drop oil into water, you will see these circular micelles being made, wherein the hydrophobic tails, they are going to be on the inner side, while the hydrophobic heads are going to be interacting with water molecules. So it's going to look like the case A. But case B is going to take place when you are going to introduce some aqueous solution into an oil ecosystem or into a fat ecosystem. Then you will see that the tails are facing outside and the heads are facing the core where the aqueous solution is going to be present. So these are the reverse micelles. The case B are inverse or reverse micelles. Now to form these kind of micelles, it's very important to have a proper concentration of both the phases, which are immiscible. And that's what we call as the critical micelle concentration. You can make use of chemicals which are cationic, anionic, non-ionic, amphoteric surfactants. All these can be used to make micelles. And the droplet size can also be controlled on the basis of the concentration of these chemicals that you make use of. Micelles have been utilized on a large scale for delivering drugs. And these micelles, if made up of nanomaterials, then that's really very biocompatible, and at the same time it's environmentally and medically safe. And that's where the microemulsions format of synthesis is gaining a lot of significance in the pharma companies. The next method is what we call as the sol-gel method. Sol is a short form for solution, while gel is very well, you know that particles in a suspension, they're going to polymerize to form a matrix which we call as gel. The sol-gel method basically is a low temperature process, and it's a very economical process, and that's the reason why majority of the companies use sol-gel method for synthesis of nanoparticles. So as said earlier, it involves making use of solid particles in a liquid and a continuous network of particles with pores filled with liquid, which we call as sol and gel respectively. Sol-gel method is going to involve usage of techniques like centrifugation, sedimentation, and then going ahead to form nanoparticles which can be used for applications in electronics, in the field of optics, space, and biosensors. Sol-gel method has also been tried in case of pharmaceutical applications like controlled drug release, wherein the drug can be trapped into the sol-gel, and that's the sol-gel of nanoparticles, and it will be released periodically. So that instead of releasing out the drug at one go, you are having a controlled release of drug over the time. This can also have a lot of environmental applications, wherein you can have some enzymes which are localized in the sol-gel of nanoparticles, and these enzymes can be released with time into the environment so that there is a continuous supply of the enzymes, especially if you are making use of this for waste management. These are some of the chemical methods which are commonly utilized in the labs, in pharma companies, in the industries to synthesize nanoparticles. But there are a lot of physical methods also. Though physical methods may not be something which are effectively utilized in pharma industries because there is no control over the size and shape of the particles. But physical methods are utilized on a large scale when it is for commercial applications, especially for coating on surfaces. There are several types of physical methods for synthesis of nanoparticles, but we will be focusing on few in our next video.